Hello everybody. Today we are going to discuss hybridization of carbon atom. Before we start, we need to explain what really hybridization represents in a case of carbon atom. So hybridization is combining atomic orbitals to form hybrid orbitals. And in case of carbon atom, we have three types of hybridization: sp3 hybridization, sp2, and sp hybridization. So before we start explaining each of these types, let's see how carbon atom's outer shell looks like. So in ground state of carbon atom's outer shell, we have two s2 electrons and two p2 electrons, precisely px and py electrons are presented here in carbon atom's outer shell. So in order to start its hybridization, carbon atom needs to convert from ground state to excited state. And how is that happened? That is actually happened by transferring one of these two s electrons from a lower energy orbital, which is s orbital, to higher energy orbital, which is p orbital, and in this case pz orbital of carbon atom is now completed. So in excited state, carbon atom is now prepared for hybridization. We have a methane molecule here, and we are going to show sp3 type of hybridization and how you can, by looking its structural formula, how you can find out that it is sp3 type of hybridization. So in sp3 type of hybridization, we have one s atomic orbital combining with 3p atomic orbitals and giving 4 sp3 hybrid orbitals. In case of sp3 hybridization, we have 4 electron density areas, which are also called sigma bond. And the sigma bond is actually formed by head-to-head overlapping between atomic orbitals. So we have 4 sigma bonds in case of sp3 hybridization. In case of sp2 hybridization, let's define it first. So sp2 hybridization is combining 1s atomic orbital and 2p atomic orbitals, which forms 3 sp2 hybrid orbitals. And we have here as example ethane compound. So how can you recognize, how can you see sp2 hybridization? You have 3 electron density areas around carbon atom in its type. Or precisely, you have 3 sigma bonds and 1 p bond. And a p bond is formed by lateral overlapping of atomic orbitals. In case of sp2 hybridization, one orbital is missing here, and that is pz orbital. So pz orbital is the one which forms p bond by lateral overlapping. And finally, we have sp type of hybridization, and how you're gonna see or recognize sp type of hybridization. You have two electron density areas around carbon atom, or precisely you have two sigma bonds and you have two p bonds, which are formed again by lateral overlapping of atomic orbitals. And in case of sp hybridization, you have two atomic orbitals, precisely two p atomic orbitals, py and pz atomic orbitals that are not hybridized in this case, and they form these two p bonds by lateral overlapping. If this video was helpful to you, please don't forget to hit the like button and subscribe to this channel. Thank you very much.